explain these all like super out of order, and I don't know which order you're gonna see them in, but the last one I'm gonna go over is number 2 because that's the one I'm going over last. Um, Number 2 was the worst. I had to use 2 chain rules and a product rule, which was awful. So for the actual equation, I had p of x is equal to 9x squared plus 8 all to the power of 6 times the natural log of 10x to the power of 5 plus 7x to the power of 3. So I decided that I needed to use the product rule in the end, but first, in order to use the product rule, I had to get the derivative of these two. And these two are 2 chain rules because we got a function like this power to the 6th. Like, I would either need to distribute it, which would like take forever, or I would need to like put it in a calculator, which would also like be kind of like cheating. Or I would need to use a chain rule, and I'd need to do the same thing for this one. So it's a product rule with a chain rule inside. So I have my function defined in terms of like composite functions. So I have p of x is equal to f of m of x, and f of x I said was like x to the power of 6, like right here. Where's my pencil? And then I said m of x is 9x squared plus 8. And then I have my h of g of x, that's being multiplied by this original term. As you can see here, you didn't put this like multiplication term, you put them together, but I knew they were being multiplied, so that's why I put the term there. So that's being multiplied by h of g of x, and h of x is this natural log because it's affecting everything inside, and then g of x is the 10x to the power of 5 plus 7x to the power of 3. So if you see here, I actually wrote it out wrong originally. I said that f of x was 9x to the power of 2. That's wrong, and I ended up doing it right later, but I'm just gonna like identify that in case you see it in the video. So that's wrong. But what I did right, and I accidentally crossed out, but you're still gonna look at it anyways because I'm not rereading it, is the h of x and the g of x. So that part I did write out right here. So h of x is the natural log. So natural log of x, that's the first equation, and the derivative of that is 1 over x. We've done that kind of problem a lot, so I've just kind of memorized it. I don't know why it's like that. You explained it to me at one point, and it has to do with like e, because it's log base e, but like, I don't know. I've just memorized it. And then g of x over here is going to be inside that, so I need to find the derivative of that. So g of x is that 10x to the power of 5 plus 7x to the power of 3. I'm going to use the chain rule to find the derivative. So we do the 5 times the 10, blah, 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 blah. And I get the derivative is 50x to the power of 4 plus 21x to the power of 2. I'm going close here because I know it's like crossed out, and I think it's not on the next page, but I just like, whatever. So that is my derivative there. Yep. And then once I get that, I'm going to go here and I'm going to put it in the chain rule, which is like the f prime g of x, because this is just like a simple chain rule. So my original like f prime right here is that, it's actually h prime for this kind of problem. It's 1 over x. So I'm going to do 1 over, and then it's going to be g of x, which is 10x to the power of 5 plus 7x to the power of 3, so that's underneath because I'm plugging it in for x here. And then I'm going to do g prime x, and that's going to be multiplied by this, and I'm going to put it over 1 so I can simplify into one fraction. Again, I apologize it's crossed out, but it's 1 over 10 to the power of 5 plus 7 to the power of 3, because this is g of x, and this is h prime x. And then this is g prime x over 1, because over 1 doesn't do anything. It just makes it one even fraction. And I'm going to multiply across, so this ends up on the numerator, and this is like the denominator. And you can see that here, which isn't crossed out, which is why I kept this page. So I have that 50x to the 4 plus 21x to the 2, and then 10x to the 5 plus 7x to the 3. So here, what I'm gonna do is I'm gonna simplify the coefficients. I think that I could have used the exponent quotient rule to kind of cancel these out, but I didn't. So I have a 50 over 10, so I can divide out a 10 from there, I think, and I can make it like You know what? It doesn't matter.